Hello everyone and welcome back to another simple science video. This is the second video on organic chemistry at IGCSE, and in the previous video we introduced organic chemistry in general. We introduced the main concepts of organic chemistry such as the formulae, the structural and displayed formulae, and the empirical formulae, and we also talked about the main features of organic chemistry such as functional groups, and we briefly mentioned the different types of organic compounds like alkenes, alcohols, alkanes. And in this video, we're going to be talking in depth about the first and most basic member of organic chemistry compounds, that is the alkanes. It is basic in its reactions, in its shape, in its properties, and so on, as I will show later on. So let's introduce the group known as the alkanes. So alkanes are molecules that are known as hydrocarbons, in that it only contains hydrogen and carbon atoms. So as a result, they will only consist of carbon to carbon single bonds and carbon to hydrogen single bonds. Okay, and their general shape consists of the main carbon chain or branches that may attach to it, which I will talk about later. So it mainly consists of a carbon chain or branches and will be surrounded completely by only hydrogen atoms. So as you can see, as I said before, they are hydrocarbons and they will only contain carbon to carbon single bonds and carbon to hydrogen single bonds. Okay? And their general formula is basically a mathematical formula with the variable n, which you can insert in a particular n, and you can find out any, in this case, any alkane. So in this case, we have ethane, whereby n is equal to 2. And for alkanes in general, the general formula for the alkane with the variable n, whereby n is conveniently the number of carbon atoms. So in this case, we have n equals 2. So the number of carbon atoms is 2. And if we were to compute the number of hydrogen atoms, we find that 2 times by n, which is 2, is 4 plus 2 is 6. So we have a total of 6 hydrogen atoms in this molecule. So therefore, this molecule is C2H6, and it is known as ethane. So let's look at how we are going to be naming alkanes and conveniently how we're going to be naming organic compounds in general. So you can see here I have 5 different types of alkanes. How do you know that they're alkanes? It's because they're hydrocarbon. And notice that the name of the alkanes will end with the same 3 letters, ane. Okay, and that's characteristic of all organic compounds. So what makes all of these 5 compounds differ from each other? So as you can see here, their names are obviously different. But what makes their names different is the number of carbon atoms in each of these molecules. So in other words, for alkanes and organic compounds in general, the number of carbons in that molecule will determine its name. Okay? So, as I said before, the only difference in these 5 molecules is the number of carbons and thus its name. So therefore, what is different in these names is the prefixes. So for example, methane and ethane are different in terms of its prefixes. So that one has a meth starting and one has an eth starting. So let's look at a convenient table that we can use to characterize the names of all the alkanes from n equals 1 to n equals 10. So for alkanes that contain 1 carbon atom, it is going to have a prefix in its name of meth. So that alkane will be called methane. And in 2, it will be called eth, and the name of the alkane is ethane, and so on. So from 1 to 10, we have alkanes: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Okay, now notice how the prefixes are quite similar in the way in which we name polygons. So for example, when there are 8 sides in a shape, we call it an octagon. And similarly, in an alkane, when there are 8 carbon atoms in the molecule of the alkane, we call it an octane. Okay, So the prefixes that we use to name organic compounds in general, you will have to remember. There's like no way of determining it really, except if you analogize it to polygons, which makes it slightly easier. So yeah, that's how you name an alkane. You base it on the number of carbon atoms, which will determine the prefix and hence the name. Now let's look at how, so basically this is how you name organic compounds in general. You have the number of carbon atoms in a molecule and the prefix as a result. So let's look at this particular compound. It is called propane. Why? Because as you said before, we talked about the prefixes. It has 3 carbon atoms in its molecule, so therefore giving it a prefix of prop, and hence the alkane's name is propane. Now what happens if instead of having a hydrogen atom attached to it, we have what we call a branched alkane group attached to it? So basically now we have one main carbon chain and a branched group attached to it, like a tree branch, okay? So now the way in which we name this molecule is slightly different. It's no longer based on the number of carbons in the main chain, but it's also depending on the number of carbons in the branch chain, okay? So similarly to the way we named the more simple molecule, we base it on this convenient table, which tells you the prefix based on the number of carbon atoms. We look at the branch. It has 1 carbon atom in the branch, so therefore it will have a prefix of meth. And the way we name this branch is going to be followed by the letters Y and L, so resulting in the branch name known as methyl. Okay, so in general, any branch that has only 1 carbon atom will be called methyl. For example, if it has 2 carbon atoms in its branch, it will be called ethyl, and so on. And similarly, we look at the main chain, which is the exact same as the previous simpler molecules. We have 3 carbons in that main chain, so therefore that main chain will be considered as an alkane called propane. So if we were to combine the names of the branch and the name of the main carbon chain, we result in the name of the total molecule, the whole molecule, of the name of methyl propane, where methyl represents the branch of 1 carbon atom and propane represents the main carbon chain surrounded by hydrogen atoms and the branch itself called propane. So we end up with a molecule called methyl propane. And similarly, we have a situation whereby there's also a branch of 1 carbon atom, but we have 4 carbon atoms in the carbon chain, the main carbon chain. And the main carbon chain's name would be butane, and the molecule's name combined is methyl butane. Okay, so back to the chart again. If we were to name the branches, we would just follow the prefixes up with the letters YL, and then we have the name of the branch, which we will connect to the front of the name of the alkane itself. So we have something like methyl propane, methyl ethane, propyl butane, and so on. Well, propyl butane does not really exist. Sorry. It will depend, as you can see later. Okay, now let's look at the properties of alkanes. So the more simple properties are the physical properties. Alkanes generally have very low melting point and boiling point due to a reason called polarity, which I'll introduce later because it's more convenient when we're talking about solubility. And the boiling point and melting point, as I said in the homologous series discussion in the previous video, will increase with the number of carbon atoms. Okay, so for any particular homologous series, the physical properties will increase gradually depending on the number of carbon atoms. Okay, now let's look at the solubility of alkanes. Alkanes are insoluble in water because of polarity, in that alkanes are considered as non-polar molecules, whilst water, which has dipoles, this is, I think, is A-level knowledge, and I'll just introduce it briefly for just for God's sake. And the truth is, polar molecules only dissolve in polar molecules, and non-polar molecules will only dissolve with nonpolar molecules. So alkanes are nonpolar molecules and water is a polar molecule, so therefore those two will not dissolve within each other. However, alkanes, which are nonpolar, can dissolve in nonpolar organic solvents. Okay. Now let's look at the chemical properties of the alkanes. Alkanes are generally very unreactive. They have a high activation energy, and they can only undergo two types of reactions. The first being combustion. We all know what combustion is, and halogenation. So let's just talk about combustion in general. Okay. So combustion means to react with oxygen. Okay. In other words, burn. Right? Alkanes can burn. And the combustion products for almost all organic compounds is carbon dioxide and water. So alkanes will react with oxygen to produce carbon dioxide and water. Now, the other reaction that alkanes can undergo is known as halogenation, or reacting with halogens, or the addition or the substitution of halogen. So in this case, we have ethane reacting with the diatomic molecule of chlorine to produce what is called chloroethane and the byproduct of hydrochloric acid or hydrogen chloride. Okay, so this reaction takes place, it must take place under UV light, which when you study chemistry at A level, you will find out that UV light is involved in their main initiation reaction in splitting up this chlorine diatomic molecule into what are called free radicals. But you won't have to remember that for the IGCSE syllabus. So just know that you need UV light to initiate this reaction. So UV light is a condition for this reaction to take place. So again, alkanes will react with halogens or group 7 molecules under UV light to produce halogenoalkanes. And the halogens that generally react with alkanes are chlorine and bromine. Those two are the most common in reactions. Okay. So again, if anything's particularly difficult, please ask me in the comment section. And let's look at how we find alkanes. Alkanes are mainly found in a mixture of what is called crude oil. Okay, and they are separated by the number of carbon chains, which will determine by the melting point, and hence we can use fractional distillation, which separates mixtures based on their melting points and boiling points, and we are able to separate different alkanes. Okay, so yeah, that's the end of the alkanes video, and the next video will obviously be alkenes. So I hope this was useful in your revision, and any questions, just please shoot them in the comment section below. Hope you like this video, and subscribe to my channel for more revision videos. Thank you very much, and good luck with your revision.